If you take chemistry, at some point you may have heard the word a mole. Now, the big question is, what does that mean and what can we do with that information? When you think about the word mole, here there's two things that could come up. The first word is the animal, the mole, digging underground, or another piece of information that is very important in chemistry is a constant. It is a unit that is used by chemists. So let's see if I can give you more information about that, because that constant came from a scientist, Avogadro. And as he put together his ideas, that is a concept that has been used by all chemists. Now, if a mole is a unit, what does that mean? Now, if you think of a mole, you have to say, what does that mean? I mentioned earlier it's called the Avogadro's constant. Some other people may call it Avogadro's number. But basically, what it is, one mole is a quantity. And what does it represent? It represents here 6. Oh, and here we do it in English. We have point. So it's 6.022 times 10 to the power of 23 particles. Now here, this is a number that represents a bunch of something. It could be a bunch of atoms or a bunch of molecules. Now I'm going to give you some analogy. When you have a mole and it is a package, a grouping of so many particles of atoms, for example, if you go to a place for supplies, you can have a ream of paper. This contains 500 pages. If you are, for example, to buy some markers, so I do buy markers for my videos, they're sold in a package of 16 markers. This one, we have a box of tissue. What do we get? We get a box here of 126 white tissues. We don't sell them individually. We package them into a group. The same way when we buy eggs, we buy a dozen of eggs. So here is important. A mole is a representation of a quantity. In order to understand what is a quantity, here's another example that could be helpful for you. If someone, for example, says that there are 3.5 dozens of eggs, this means what? It means that we have 3.5 dozens, and we know that there are 12 eggs per dozen. Now, if we do some math, we know that we can cancel out these, uh, these units. The only thing I have left are therefore eggs, and therefore I have here 3.5 times 12 eggs, and here I have a total of 42 eggs. So what did I do? I used a unit, so a dozen is a grouping of a certain element. Therefore, here's the same thing. A mole is a grouping of so many atoms and so many molecules. How many of them? 6.022 times 10 to the 23. I know it's a huge number, but it is the reason for that is that particles are so tiny that at some point you need a lot of them for us to be able to measure them and to know how much of each atoms or how much each molecules we have. If you realize that you are learning quite a bit, don't hesitate to subscribe to this channel. I'm going to create some videos on chemistry and other scientific topics. The reason is I've been teaching science for 25 years. I'm more than happy to share what I know. And in exchange, I want you to put in the comments below any clarification questions you may have or any questions, something you want specifically for me to answer, because I will use your questions and your comments to make more videos. You'll see, it'll be exciting. Now that we've talked about a dozen eggs, let's see if we can use the natural example with moles. So let's see what we have. Here I have an example where I'm mentioning that I have 3 moles of aluminum. So here I'm talking about specific atoms. So that means that I have 3 moles of that atoms, but each mole here we know is 6.022 times 3 to 23 particles per mole, like this. So that means that we can simplify our units. Moles here and mole will simplify. We end up with 3 moles of aluminum gives us 3 times 6.022 times 10 to the power of 23 particles. We do the multiplication, we end up with 18.066 times 10 to the power of 23 particles. So we know that 3 moles of aluminum is this many particles. Now, if you've played with scientific notation, you know that 18.066 times 10 to the power of 23 can also be written. So if you move the decimal point here, is equal to 1.8066 times 10 to the power of 24 particles. Now you're going to say this number is so huge, I don't know what it means. Now, there's a reason why this number becomes important, and soon I'm going to share with you the relationship between the concept of mole and what information we find on the periodic table. A moment ago, we took a number of moles and we transferred them in how many particles we have. Now, it's important, it's part of doing some math in chemistry, and it allows us to understand the size of the samples we have. So here's another example. If it happens that I have a situation where I tell you, and here you'll see the numbers work very well, if I have 24.088 times 10 to the 23 particles, I would like to know how many moles that gives us. So here we have to do some math again. If I know that I have 24.088 times 10 to the 23 particles, and I know that for 1 mole, I have 6.022 times 10 to the power of 23 particles, I can do some simplifications here. I can take particles here and particles here. It is simplified. What I end up with mole, which is my unit. So here I have 24.088 times 10 to the power of 23 over 6.022 times 10 to the 23. My unit is in mole, and therefore, when I divide this fraction, I end up with 4 moles. So what do we have here? 4 moles are 24.088 times 10 to the power of 23 particles. Now here it's interesting because in the previous units, I know that you have learned about chemical equations. You've also learned how to balance equations. And here this is important because when you balance equations, you are making sure that whatever reactants you have and whatever products you have, the mass of both sides need to be equal. So here we're talking about mass. So soon you'll notice that if I have a specific number of particles in a mole, is it possible for me to have specific units that we can use for each of the elements and each of the molecules we have in our society? And that's when it gets very exciting, and this will be my next examples. If you have clarification questions or you want to know something else, put the questions in the comments below. I always look at those, and I'm going to use your comments, your questions, to create more videos just for you. And the purpose for this is I want you to get better, and together we can certainly do so. On this, I'm going to put here a link to another video you can go and watch. On this, be great, and I'm sure we'll succeed together in chemistry this year.